Hello and welcome back. Okay, in this case, I want to show you, this is going to be part 3 of the substitution rule. And so I'm going to show you a problem that gets a little bit harder. It took me a little bit of trial and error to get it right until I realized that there was no easy substitution in there. It gets a little bit more complex. So I'll show you where to go when things don't quite match up as well as you had hoped. Okay, so let's take the problem. If we take the integral of x squared over 1 minus x, and we'll take the derivative of that, okay? So if you remember from what I was telling you, you have something trapped in here. So if that was in the form of square root of u, then you would know how to integrate it. In this flavor, you were forced to do a substitution rule. So you want to target that one, but if you notice the power of this x isn't going to allow you to cancel out that x squared at the top. So it's going to leave you with some choices. So other things I was looking at is, was there any type of substitution that I could take out this square root and like basically what I'm trying to say is turn this into a u squared down here, and then it was getting close to getting some choices for how to integrate that, where basically u squared would equal x, or inversely u would equal the square root of x. Went down that path. It didn't work out too well for me. So I'm going to cut it off there. And if you do find yourself going down something that just doesn't seem right, you want to go back to the beginning and see what your choices are. In this case, I'm going to go u equals 1 minus x, du equals minus dx, dx equals minus du. Okay, so let's substitute that in. We're going to go from x to u domain, and we're going to start putting things in. So I have here, let's see, x squared over u, and then my dx is just going to simply be negative du. So nothing cancels. I still have an x squared there, which is bad. I can't do anything about that. But if I take this definition up here and I say, okay, well, what does x equal in terms of u? So in that case, my x is going to be equal, you can see how they'll swap around it, 1 minus u. Okay, so I'm going to use this guy here to substitute in to get rid of that x there. So I still have my integration, 1 minus u squared over square root of u. And I have a minus sign out here. I'll just carry it like that, du. That guy just goes to the front. Okay, so now what do I do? Well, I can actually just factor that top part out. 1 minus u, 1 minus u, du over. So I'm more hopeful now because I'm going to be able to factor this guy out and get, let's see, 1 minus 2u plus u squared du over square root of u. That's a nice simple denominator, and I have addition signs in my numerator, so I'm going to be able to take that guy and just separate it. Go 1, 2, 3. So I'll write it over here. So once I do that, I can separate my whole integral. So I'll take it one step at a time so you can see better what I'm doing. Okay, so 1 minus square root of u minus 2u over square root of u plus u squared square root of u du, the whole thing. Okay. So if you remember, it makes life a lot easier. So I'm going to take this negative sign, I'm going to distribute it back into there just to get rid of it. And then I can see minus this guy becomes u to the negative 1/2 plus, that is a plus because of those two. And then I've got u to the 1 minus 1/2. So it'll be 2 to the u to the 1/2. Okay, hopefully you understood what I just did there. And then it's going to be minus the integral. I have u to the 2, so it's going to be u to the 3/2 there. And I forgot all my du, du, du. So I can integrate that, and that. So I'm going to do that. And I'm going to come down, and you'll see this one come to here. And so that's going to turn out to be, just always let me think about it for just a second, minus 2u to the 1/2. And then it's going to be plus 2, and that's going to be times 2/3, u to the 3/2. And then we're going to have minus 2/5, u to the 5/2 plus c. Okay? So then we just have to substitute back in our x's at that point. So u is going to be 1 minus x. So negative 2, 1 minus x to the 1/2 plus, and this is 4/3 times 1 minus x to the 3/2 minus 2/5, 1 minus x plus c. And so that is your answer. So hopefully that helps. Just a little bit different than simple substitution. We didn't have things that canceled out gracefully. So we just had to use our original definition of u, solve for x in terms of u, plug that into the equation to get rid of any remaining x terms. And then luckily, everything came together at that point. We were able to separate out our integration and just work it simply. So anyway, I hope that helps. That'll be the end of part 3. Subscribe to the channel, and I'm not sure if there's going to be a part 4, probably, because there's some other types of problems. Anyway, good luck. Thanks.